Hey everybody, welcome to day 8 of NTI. Before we get started today, I know on day 5, I'm going to take those off because I got a blue glare. I know on day 5, Miss Beck shared with you guys scientific calculator that you could use this on your smartphones. I know a few of y'all have reached out to me saying that you left your calculator at school. Makes it kind of hard to do this without that. So you have your smartphone if you have one. If not, and you're watching this video, that tells me you have access to the internet. So what I'm going to do is I'm going to show you guys really quickly. I'm going to share my screen here. A calculator that we can use. That's a scientific calculator, just like the ones that you guys are using at school. All right. So if you type in Google Desmos Scientific Calculator, you can even choose that section on there. It's the very first thing that pops up. All right. For those of y'all who did the field testing for math, this is the same exact calculator you guys got to use on field testing. All right. So it has all the functions there that you need, your add, subtract, multiply, divide. Has a button over here to where you can put fractions in. Oops, sorry about that. All that good stuff. Just make sure that if you're putting in the fraction, you have your cursor in either the numerator or the denominator, whichever part you're trying to type into before you try to type it, right? So, and then over here, it'll tell you what your answer is and allow you to convert that to a decimal if you'd like. So that's just something that I wanted to share with y'all before we got started with the actual work. So I'm going to stop sharing my screen here so that I can talk to you guys full screen. Our day 8 topic of NTI is review of the area of quadrilaterals and triangles. Now you may be thinking, we talked about this last year in 6th grade. You did. That's why it's review. All right. And part of the reason why we're going back and reviewing is, one, it's been a little while since y'all probably did this. But 2, the next thing that we're going to be doing after we get through with this review is we're going to be moving into area of composite figures, which just means you'll have shapes made up of other shapes. So maybe you'll have a rectangle with a triangle on the end of it, or you'll have a box with a circle on the inside of it that you'll have to find the area of the space between the two. So because of that being incorporated from 6th grade into our 7th grade stuff, we're just going to take today to review that material. All right, so without further ado, I'm going to make sure that I share my screen correctly this time, because this is my second take. I had to do this whole thing over again because I didn't share the screen the right way. So I'm going to make sure I do it the right way this time. All right. So hopefully you guys are all seeing this area of parallelograms, triangles, and trapezoids. All right. So we're going to start with parallelograms. Oops, sorry about that. So let's just zoom in here on this. Now, with parallelograms, the formula is very basic. All right, and the formula is very, very basic. It is A for area is equal to B times H, where B represents base, if you don't remember that from last year, and scoot that over a little bit. H represents height. All right, so while we're working on area of parallelograms, triangles, and quadrilaterals, those 2 variables are going to be used in all 3 formulas, so it's good to know what they mean. All right, so this very first, very basic one here. With this parallelogram, we've got 5.9, and that is my B, my base, and 4 is my H, my height. All right, so now that we have these 2 things identified, whatever calculator you're using, if you have yours at home, if you're using your smartphone, if you're using the Desmos calculator that I just shared and showed you guys, you're going to substitute this information into the formula. So A is equal to BH. So B is our base, 5.9 times for our height. And for this problem only, I'm going to go back and I'm going to share with you the calculator just to show you how we would do that. All right, so in the calculator, right, let's clear out what I had before. You would just type in 5.9, your decimal points there by the 0, times 4, base times height gives you an area of 23.6. All right, so let me go back to that whiteboard that I had a minute ago. And we have an area of, like I said, 23.6. And the units for area, remember, are always square units. So you could write that inches to the power of 2, or if you just want to abbreviate SQ for square, I'm happy with that as well. All right, so now that we have done that first very easy example, right? Sometimes whenever we're given area of these shapes, we're given more information than what we really need. So my hint for you guys, and I tell this to everybody whenever I'm helping them out with area of parallelograms, quadrilaterals, triangles in general, look for this little symbol right there. You guys should know what that means. It's a 90-degree angle, right? That's a right angle. Any time you guys see that 90-degree symbol, that will be connecting the base of that shape to its height. All right, so it tells me 6 and 5 are the base and height for this particular parallelogram. Now you may be asking, well, what about these 5.8s out here on the side? They're not needed. That's just extra information there to throw you guys off. All right, so we would just, again, take that formula. A is equal to base times height. Our base is 6 times 5. Hopefully y'all don't need a calculator for this one. 6 times 5 is 30 square meters. And if you did, that's okay. No problem at all. All right, so that's area of parallelograms. Really easy. Just a simple multiplication problem. All right. Area of triangles. The formula is similar, but it's a little different in the fact that we use 1/2 base times height. So you'll notice there that BH is in there for base times height from a parallelogram. That's because, think about a parallelogram, I cut it in half. I've got 2 triangles there, right? I've got a triangle here whose area is half of that original parallelogram. So that's where that comes from. Or some people like to say base times height divided by 2. Whichever way you look at it, it's the same, because think about it. When you take half of a number, what do? You divide it by 2. So for our first triangle that we have here on the left, we've got our base of 7, our height of 6.6. I'm going to have to put my glasses back on. Area is equal to 1/2 base times height. So you would do 1/2 times 7 times 6.6. Now, before I do the problem there, if you want to use the decimal 0.5 because it's easier for you to type that in your calculator, especially if you're using like your smartphone, I'm fine with that. I'm sure Miss Beck is fine with that too because they're equivalent. So feel free to use 0.5 instead of the fraction 1/2. Just know they're interchangeable. All right, so we could do 0.5 or 1/2, whichever fraction you're using, times 7 times 6.6. And that gives you an area of 23.1 square yards. All right, and that would be our final answer there for that one. Not bad, right? So I chose this second triangle here that we're looking at because you'll notice that instead of the height, like on the first one, I'll just get a highlighter here. The first one here, the height is in the middle of the triangle. It's a lot easier to identify. On this particular triangle on the right, though, you'll notice that you've got this dotted red line out here to the side. Again, just look for that right angle symbol. That will connect your base to your height every single time. Base to height. All right, so again, that 19 kilometers, since it's not the base or the height, I don't need it. I don't have to use it. Okay, so for this second example, I'm just going to set up the formula for you. You want to take this one to just do some practice on your own. That would be great. It's the same process every single time. As long as you can identify the base and the height and plug it into the formula, you're going to be great with this. So we got 1/2 base times height. The base is 11. My height is 7.7. And then you guys can find the area from there. All right. So let's move over to trapezoids. All right. The area formula for trapezoids of the three is the most complicated. But again, if you can identify that base and the height, it's actually really easy. All right. So the area of a trapezoid is 1/2 times the quantity of B1 plus B2. Now, B1 and B2 here are standing for base 1 and base 2. Okay, so on any trapezoid, it's a four-sided shape, quadrilateral, but the one characteristic that sticks out about a trapezoid is that it only has two parallel lines, right? Some of the others, you have two pairs of parallel lines. A trapezoid only has one. Those pairs of parallel lines are the bases. Now, if you don't remember what parallel means, it means that they're never going to cross, they're never going to touch, they're always going to be the same distance apart. All right, so if you think about it, on this trapezoid to the left, that 4.1 and that 10.9, that's my base 1 and base 2. It doesn't matter which one you call B1 and which one you call B2. All that matters is that you're using the bases there. All right, because remember, with addition, order doesn't matter. So that's why it doesn't matter which one you pick. All right, but just out of habit, I always pick the one that's on the top as B1 and the one that's on the bottom as B2. That's just what I do. So you've got 1/2 times the quantity of base 1 plus base 2 times the height. All right, so again, I'm going to use 4.1 as B1. I'm going to use 10.9 as B2. So with my formula, I'm going to go on ahead and write that out. So B1, so we're going to call that 4.1 plus B2, 10.9 times my height of 5. And again, look for that right angle, right? Look for that right angle symbol. Oops. Look for that right angle symbol. It connects the height to the base. All right. Now, since we have this set of parentheses here, order of operations tells me I need to do that first, right? Or I could distribute the half. I just find it easier to do what's in the parentheses first. So I've got here 1/10 and 9/10. That makes a whole. 4 plus 1 gives me 5. 5 plus 10 gives me 15, right? Or if you have your calculator, you can just type that in there and it'll do it real quick for you, right? So now we just need to do 1/2 times 15 times 5. So 15 times 5 gives me 75. divide that by 2 or multiply it by 1/2, whichever way you choose. And I get 37.5. And this time it's centimeters squared. And I'm done. That's it. It looks a lot more complicated than the other two, but again, it's really not. Okay. This right hand one, again, you're given more information than what you need. So look for that right angle symbol. Look for that right angle symbol, and that will tell you your height and your base. All right. So those 6's and that 6.7 that's out there on the side, those aren't needed. Again, extra information to try to trip you up. But you guys are good. You're not going to get caught by that. So A is equal to B1 plus B2 times H. And again, on this second example, just going to set it up for you. I'll let you guys try this one on your own once I get it set up. And then you guys can just, practice using those online calculators that I showed you a minute ago if you're choosing to use one of those, or your smartphone or whatever you're choosing to use for your calculator. So base 1, I said let's make that base 1. 6.4, let's make that base 2. So 1/2 times 13.6 plus 6.4 times my height of 5.2. And then again, you guys can go back in there, fill in the blank for me, figure out what that area is, and remember, area is always in square units. All right, that's very important. So with that being said, that was our review of area of quadrilaterals and triangles. Tomorrow for day 9, just like what you guys had after circumference of circles and area of circles, you guys are going to have a quick little formative over the area of quadrilaterals and triangles. So if you guys have any questions, don't hesitate to reach out to Ms. Beck or myself, depending on which one of us you have. And we will be more than happy to help you guys out. You guys just keep working hard. You guys are doing awesome. We're going to continue to work through this together. And if you guys, again, have any questions, feel free to reach out. Have a great day, guys. Hopefully we'll see you soon.